Next up, we have Clint Gibler with DevSecOps State of the Union.
Hey everyone, thank you very much for coming, and thank you to the organizers for having me. I'm very excited to be here. So there's been a lot of great talks over the past year or two in the security automation or DevSecOps space, and the point of this talk is to try to gather and organize some of the great work that's been done and provide references to specific topics that if you want to learn more about, you can follow up there. So I'm going to attempt to reference about 40 talks in this 30-minute talk, so let's begin. First, a little bit about me. So I'm a research director at NCC Group. We do penetration testing of pretty much all the things. Most recently, I've been involved in a number of sort of staff augmentation type work where we're helping companies roll out security automation or tuning SaaS or things like that. So I've seen a lot of this firsthand. I'm also a co-founder of a small company called Practical Program Analysis. We focus on sort of automated bug finding techniques. So before my current job, I was a PhD student at the University of California, Davis, where I dressed like this. And before that, I lived in the Midwest, where I dressed like that. True story, I looked up some like generic stock photos for farmers, and then I realized I actually owned that shirt already. Yeah, I found that out this morning, and I thought it was too good to resist. So what are we going to talk about today? So a couple of things. First, a couple of principles and themes I've seen across many different talks, and then some specific examples in that space. I'm going to talk about some specific talks that I think are especially neat because they involve eliminating bug classes. I'm going to talk about a sort of case study of a project I was on with NCC Group, where we helped a company try to do that as well. I'm going to look at a blue team truism that I've recently been thinking might be wrong. And then lastly, we'll do a blitz of a bunch of other useful talks. OK. So first, let's talk just very quickly about minimizing developer friction. So this is something pretty much every DevSecOps talks mentioned a little bit. So some examples of this are rather than having a separate security tool system and making developers go to that, instead integrate as much as you can into the developer workflow. So perhaps creating security issues as Jira tickets, or just basically streamlining everything as much as possible. If you are using tools and you're trying to push results directly to developers, ideally these are almost always true positives, because once it gets even above like 5% or so, you start losing developer trust. And then this idea of like a paved road concept. So Netflix talks about this a lot, but basically the idea is how can we make the default very simple, very easy, and actually just better to do it the secure way than to just go do it sort of the standard their own way. So one example of this is John Heisman at DocuSign. They wrote a secure wrapper library for XML parsing. And basically, not only does it prevent against XXE, it also gives the developer some nice telemetry. So developers want to use it because they're like, oh, hey, I want to know who we're reaching out to over the network. I want some performance metrics. So you have this nice developer win bundled in with a security win. And I see this a bunch of places. So let's talk about some of the other themes in a little bit more detail. OK, so one idea is self-service threat modeling, right? So you don't necessarily have time to meet with every single development team one-on-one to like threat model each new, say, epic or feature release. So Slack, a couple of years ago, released this tool called GoSDL, which basically is sort of a questionnaire developers can fill out that's like, you know, what are you touching authentication? Is this externally facing? What languages are you using? Basically, here's some things to consider. Also, Netflix has a questionnaire as well, and Google has a vendor security questionnaire. So not quite the same, but I know some companies who have sort of customized the prompts in their tool to be more of like a threat modeling for developers. So here's a quick screenshot of some of the things Netflix asked their developers to think about. OK, so a couple of more talks in this space. So this one from Cohen of Riot Games at AppSec Cali. So what was interesting about this is rather than having a separate process, they basically just created a culture of, OK, anytime you're building a new service or a new feature, what's like one simple question that we can get developers to discuss amongst themselves to make them more security conscious and sort of plan security in from the beginning. So again, it may not cover everything, but here's at least one thing that can at least get some coverage. So, you know, for this new thing we're building, how can a malicious user intentionally abuse this functionality, and then how can we prevent that? So quick, simple, because it's so easy, it's more likely to be adopted. And then also, Izar, talk from Autodesk, mentioned PyTM and some other things as well. OK, so next idea. Rather than having your SOC look at every single alert that comes along, which might be very time intensive, how do we focus on the things that are more interesting? So the idea is when a user triggers a potentially fishy event, let's send them a message from a Slack bot saying, hey, it looks like you just tried to do sensitive action like sudoing and prod or something like that. Hey, was this really you? And you sort of 2FA push them as well. So the idea here is, can we push some of this validation to developers to save us time? So this was originally talked about by Slack in a blog post. Dropbox thought that was a great idea, so they did it as well and released a tool. And Pinterest talked about this most recently at this past AppSec USA. OK, so continuous visibility. So one, I think, common challenge is knowing what are developers working on. You can't be everywhere at once. So Doug DePerry of Datadog talked about, hey, where are developers communicating, and can we try to infer where we might want to reach out to them? So by potentially like scraping Slack or Trello or Jira for security tags, or hey, they're mentioning crypto or security or something like that. Maybe we want to reach out to them. And then having this idea of a risk dashboard. So what is sort of the current state of our different services? So Domino's at AppSec USA gave an example of like for each service, what are the components, and do we have known vulnerabilities in those? Like, do we have good coverage? And then Netflix, again, had something as well. So I don't know if you can make this out very well, but it has some interesting attributes in terms of, are they using the TLS library that we built? Is the service edge-facing? How many AWS instances do they have? And so forth. So it gives them sort of like a nice, quick, high-level view. OK, so one of the biggest, most continuous like through threads I see everywhere is this idea of an AppSec pipeline. So people are writing code and pushing code all the time. How do we continuously scan it with static and dynamic tools? So I saw Twitter originally talk about this, and then Salesforce did and released a tool, and then Netflix did and released Scumbler, and then PayPal talked about it, and then Coinbase did and released a tool as well. So lots of people think this is a good idea. So those were more on the tool side. This is more on like the process and lessons learned side. So I want to call it the second one. Both are good, but I think the second one is interesting because they have a section of like, here's some unexpected bumps that we didn't foresee that ended up being important in practice. So I thought that was very nice. OK, we're doing well so far. Let's keep going. All right, so some neat talks on eliminating bug classes. So as AppSec professionals, it's nice to find bugs and to fix them. But I think what's nice is solving bug classes, right? This is where like your scalable wins come in, because you're not just like whack-a-moling individual bugs. So here's a couple of talks that I think were especially good in this space. And there's probably more that I don't know of, but here's some that I personally like. OK, so the first is from Travis of Netflix. So the idea here is developers at Netflix can create new services without talking to the security team, and all of these services get like a base set of AWS permissions. And what RepoKit does is it basically gathers data about how the app is behaving, and then periodically takes permissions away, and then watches the app to see if it fails. So if it does, then it gives the permission back, and if it doesn't, then it assumes, oh, it didn't need this permission. So what's really cool about this is without ever talking to the security team, without developers having in-depth knowledge of how AWS permissions work, which is quite complex, you're just gradually converging on this steady state of least privilege. So apps that aren't used converge to 0 permissions. So I think this is pretty awesome. So the next one from Will of Netflix is how do we detect use of compromised AWS credentials outside of our environment? So there's been a number of high-profile cases where people, where companies have had credentials leaked or published to GitHub, and it's resulted in thousands of dollars of AWS spill, or even a company closing down because all of their backups were deleted and source code was deleted, and sort of like a game over scenario. OK, so let's just quickly talk about how the flow overall works before we get into the details. So You have an EC2 instance, which calls assume role. So this is getting some credentials back from IAM. These credentials can then be used to interact with the AWS metadata service, which then allows you to talk with other services. And meanwhile, AWS CloudTrail, which is another service, is logging all of these API calls. So high level, this is sort of what we're working with. So this technique works by making a strong assumption at the beginning, which is the first use of a AWS credential we assume is legitimate. So when we see a new one, we assume that it was done by a service we control, and in the first use was not an attacker. So if you make this strong assumption, then you can say, if we see the use of an AWS cred from an IP that we haven't seen use this assume role API call, that is something that we've sort of added to this table that we're iteratively keeping track of, then a credential has been exfiltrated from our environment, and thus we should alert. So Will gave this very non-intimidating diagram about how it all works. So let's quickly talk about it. So basically, we're continuously watching CloudTrail logs of which API calls are happening. And then if you see a call to assume role, we basically have this table we're keeping up to date with a mapping between the source IP and the AWS credentials being used. So like, OK, we saw this IP using this one using this one, and so forth. So if we see a API call that's not assume role, we check if the current user, that is the assumed role, has an IP in our table. And if it does, then it's like, OK, cool, this is expected behavior. But if we see a source IP that's not in our table, then we alert because this is likely a compromised credential. So Will actually released a number of proof of concept codes for this implementation, is the first two links. And the third link is a example metadata proxy, which basically can block a service from hitting the AWS metadata service at all to sort of prevent the creds from being leaked in the first place. So what we just talked about is like, how do we detect it? And then this is ideally preventing it from ever happening. And he said that this was able to significantly restrict the impact of bug bounty submissions in practice. Like they found an SSRF, and he was like, cool, try to hit this metadata service. And then they were really frustrated. So they did a follow-up talk, Will and Travis, about some other stuff that's also worth checking out. OK, cool. So this is from Max of Airbnb at CCC. So a challenge for many companies is you have this crunchy exterior, soft interior, right? So how do you switch to a secure internal network while not halting development and starting over, right? So if you have 1,000 engineers and tons of services and say hundreds of deploys a day, you can't really say like, hey everyone, please like stop working for a couple days or a week while I change things, right? Because that's going to cost hundreds of thousands or millions of dollars in lost productivity. So the goal here is how do we stay out of the way of engineers? Ideally, this is transparent. Can we make it secure by default? And not just that, but also make it difficult for it to be insecure. And ideally, this is also agnostic to what language or framework the service is using, what protocol is being spoken, all of those things, because you don't necessarily know how things are going to work in the future. So he described it quite nicely in 2 sentences, and we're going to break this down in a couple of slides. So basically, you use mutual TLS in service discovery for authentication and confidentiality. And you discover access lists, that is, what service is allowed to talk to what, automatically. So it's basically zero config security. OK, so let's look at how this works. So each node here at the top represents a service in like a microservice architecture. So each service has a X509 certificate for identity. The communication between each service uses mutual TLS. So unlike when you're browsing the web and the TLS you're using allows you to authenticate the server you're talking to, for mutual TLS, the server also knows who's talking to it. So it's sort of bidirectional identity is known. And then the third part is you have this authorization map, which is basically who can talk to who. Because ideally, you want to restrict nodes to only be able to talk to who they need to be able to talk to. So if an attacker compromises one, they can't talk to, say, more privileged things that that service shouldn't be able to talk to. OK, so originally, this is how their service-oriented architecture worked. So they have in service A on node 1 and then service B on another node. So they have a local reverse proxy that service A talks to, which then talks over HTTP to service B. So what they changed this to is they actually added a reverse proxy on the receiving service that handles the mutual TLS. So what's really neat and clever about this approach is that this mutual TLS is transparent to service A and service B. They don't need to know or understand anything about it. And what Max said in the talk is that they were actually able to deploy this without changing any code from any of the services that the engineers wrote. So basically, it was just handled transparently, which I think is very, very cool. So the last part of this is, OK, we have identity, we have secure communications, but how do we know who should be able to talk to who? So the interesting insight here is you actually already know this information if you use a config management tool like Ansible, Chef, or Puppet. So for Airbnb specifically, they use Chef to configure services. And in those scripts, they already have these attributes that say, OK, this service needs to be network connected to this other service. So they basically wrote a service that continuously watches Chef scripts and then parses out these connections. And then these connections are continuously enforced at a network level as well. So you can imagine if you didn't have a clever trick like this, you would have to have like 5 engineers spend a day building the mapping about what can talk to what, and then it's immediately out of date as soon as you do it. So you're going to spend a ton of time for not much benefit. But I thought this was very clever, and I liked it a lot. OK, so next talk. So this is from Hongyi Hu of Dropbox. So the idea here is how do you scalably protect a massive number of heterogeneous internal apps? So for most companies, you have one or a handful of public-facing applications, say like Dropbox.com, that has a very well-defined tech stack. The security team has put a lot of time into hardening it, making nice secure wrapper libraries, making nice tooling. So this is like locked down. But for internal applications, that is things that are not externally facing, oftentimes developers can use whatever they want. So there's hundreds of frameworks and libraries, and it's difficult to sort of scale your efforts there. So initially, you might say, oh, let's just firewall it off. Let's say we have like some services where you can debug prod or like business analytics. So like, oh, let's just firewall them off so people can't access them. Unfortunately, that doesn't work for, say you have users on your internal network, like employees who could be CSRFed or attacked by DNS rebinding and things like that. So that would allow external attackers to still reach these internal services, even if there's a firewall. And to put out a shameless plug, some colleagues of mine built Singularity, which is a pretty neat DNS rebinding tool. So also, if you already have an attacker on the inside, again, firewall doesn't help. Or if you're interested in the internal abuse case, again, a firewall is not going to help. OK, so to cut to the chase, the idea is having a proxy. So all employee browsers talk over TLS to the proxy. And then also the proxy has a TLS connection to the internal services. So what's nice about this is it has a centralized, scalable platform that you can build defenses into. So each application written in many different languages on many stacks don't have to build these protections themselves. And this is also useful for other security teams, like the infrastructure security team, detection and response, and so forth. So Hongyi gives a couple of pretty awesome examples. So one is doing CSRF without necessarily caring about what language and framework the internal apps are using. He also talks about content security policy. Spoiler alert, it's still really hard. But he also talks about detection and response and some other things. So I would encourage you to check this out. So yeah, I noticed after writing these proxies seem to be pretty hot. OK, so last one in this. So one thing that I think that's interesting is, so coming from a pen testing background and like manually finding bugs, you're using like an IDE or perhaps a proxy like Burp or Zap. And then on the other end of the spectrum, you have some commercial static and dynamic analysis tools that are trying to like black box solve all your problems. But what I think is interesting is in sort of the middle and maybe the human augmented space. Historically, there was kind of this desert of sadness. But there's a couple of new players in this field that I think are interesting. So one is Semel, which is a number of UK academics built a static analysis company. And their primary thing is this query language, or QL, that finds bug variants. So given a bug that's interesting, let's find other instances of that. And they found some cool bugs. Another company is Shift Left, which is building a tool called Ocular. So if you're familiar with Yawern, this is basically a commercial version by Fabian Yamaguchi and others. So basically, this gives you a REPL that you can query for different code patterns and do like data flow analysis sort of interactively in a console. And the original paper, I think, is this bottom link. But he's done a number of papers that are really awesome, so I encourage you to check those out. OK, doing good. 10 minutes left, time to do it. OK, so I want to describe a case study of a client project that I was on that's very interesting, both because I think the methodology might be useful for you, as well as some of the results surprised me. OK, so a company came to me saying, hey, we're paying a lot of money for this SaaS tool, and we're not getting a lot of value. Can you help us figure out what to do with this? So I'm going to talk a little bit about how we scoped the problem, our methodology, like what we did, what we found, and then how you can do this too. OK, so initially, this project is a bit vague. More value, like what does that even mean? At first thought, you might think, OK, well, let's try to maximize the bugs found and then divide that by the cost of the tool, and boom, you have your security ROI. But there's a lot of hidden costs there, right? In reality, integrating the tool into your CI/CD pipeline, tuning it, the AppSec engineer time triaging, that's all a non-trivial amount of cost. I don't know any company that's like, oh, we've got plenty of AppSec engineers and they have so much free time, they're just twiddling their thumbs, right? That's never the case. And ultimately, I think what's important to think about is, if we just have someone manually pen test all the things, is that going to give us better bugs than using this tool? Because if the answer is yes, then don't use the tool, right? That doesn't make sense. So ultimately, the success criteria here is, given a limited, realistic AppSec engineer time and budget, what's the best use of our time to reduce overall risk? And the company was already doing all the things that you should be doing, like threat modeling, secure libraries, SAST, custom linting, internal and external pen testing, bug bounty, and so forth. OK, so the intuition behind what we did is that prior bugs are likely indicative of future bugs, right? So there's always unknown unknowns, but I think in most cases, this is a reasonable assumption. So the core idea for what we did is let's review all prior known bugs over the past couple of years and determine, is this suitable for static analysis? So first, we worked with the security team to group a bunch of prior bugs by categories. So this is XSS, this is Open Redirect, and so forth. Here's the PR fixing it. And here's some meta information. And of course, we needed access to the code and the SAS tool and Jira and so forth. So in terms of the project work itself, basically what we did was review as many bugs as possible, and then tried to see, could we have detected this with grep? Did we need some abstract syntax tree type matching? Did we need data flow analysis? As well as what mitigations and checks are already in place. So the company already had some custom linting that was already finding some things, which was awesome. And also, we did some research in terms of in the languages and frameworks you're using, is there some primitives that we could use? So let's say the SAS tool isn't useful. How easy is it going to be to roll your own? Because ideally, there's some stuff to build from, and you're not starting from scratch. OK, so what was the output? It was a report, basically the first part with, here's some overview of static analysis theory, just for your reference. Here's what we've seen using tuning SAST in a bunch of other companies. But the main body of it was, OK, for every vulnerability class that we were able to look at, does it make sense to use SAST? Should you instead have built some custom tooling? Should you write a secure wrapper library or something else? And of course, when you make recommendations like this, you have to keep in mind, what technology are you using? What does your SDLC look like? Where's the product going in the future? And so forth. OK, so what we found, some things confirmed our intuition, and some things were a bit surprising. So the first is that secure wrapper libraries, for example, they built one so all access of user data had to go through this wrapper library. It killed SQL injection, so awesome, that's what you hope to see. As does modern frameworks. So new code was written in React, and then there was legacy JavaScript as well that hadn't been ported. So anytime there was XSS, it was in the old code. So I think both of those are things as AppSec engineers you want to believe, but it was cool to see the data back this up. So for surprises, for this, I never thought as a security consultant I would say, for this type of security issue, don't care about it, it's fine. But ultimately, for things that are pretty infrequent, or it's always low severity, or it's just going to be mitigated completely by upcoming stuff, honestly, that's kind of the real answer. So I really like static analysis. I think it's awesome. And so I really wanted the answer to be, oh, let's build this crazy complex rad static analysis tool. But what I found is that writing a secure wrapper library and custom linting in, at least for this company, in their tech stack, was much better than SAST in general. Because most of the vulnerabilities were not something SAST tools are generally designed to find, like access control bugs, or they required extensive custom rule writing, which for this tool was not easy and very time intensive. So I found this interesting because data flow analysis, which is sort of the selling point of most SaaS tools, at least in this case, would not have helped too much. OK, so how to do this at your company? So 2 things. So first, track your vulnerabilities. So if you can group these by code base as well as type, like access control, XSS, et cetera, is very useful. Ideally, you also have access to the pull request that fixed it, so you know what does this bug look like, and then how does the fix look like. And then also, how do you find them, right? Pen test, bug bounty, and so forth. One trend that you might find interesting is one of these finding most of the high severity bugs, and how much is this costing you? And keep in mind, obviously, time as well. And then once you have a bunch of these, review the vulnerabilities, and then think, like, what can find these or prevent them entirely at scale? And obviously, you want to minimize cost and time. Another interesting thing is, has your org or team had other nice wins in the past that you can leverage? Different cultures mean different solutions are more or less effective, so it's always important to keep that in mind. OK. So one thing I've been thinking recently that I wanted to mention to you all, and I would love to have your feedback, is historically as a community we've been very focused on finding all of the bugs. And there's been a huge number of companies that we collectively have spent billions and billions of dollars with to find all the bugs. But I think most people would agree that there are still bugs. Right? And one thing my friend Zane said recently is that historically security has been based on the flawed assumption that we can find all the bugs. Right? So, but bugs, I think, are always going to exist as long as you have a non-trivially sized code base. And tools generally can't find every bug. There's always going to be false negatives. So in access control or business logic flaws, or just fundamentally the flow is too complex, or you don't have enough context. And you can try to turn the tool knob up to being as over-approximate as possible, but then you're going to get drowned in false positives. So one thing I've been thinking about recently that I've been starting to chat with people about, specifically Scott and Zane have influenced my thoughts in this space, is I wonder if the next trend in security is secure defaults and then lightweight adoption checks to make sure you're using them. Right? So would you find interprocedural data flow analysis of backend code, tracing that through multiple microservices into like a very complex front-end code? Would you rather do that? Or would you rather grep for dangerously set inner HTML, which in React turns off the output encoding? So I think this idea of like detecting use of secure defaults or the lack of use is just really an order of magnitude easier problem than finding bugs. So this is something I've been thinking about. I'm still thinking about it. So if you have thoughts, I would love to hear them. And then in the real world, obviously, you want logging and monitoring as well for visibility. OK, cool. Let's do it. Finish strong. OK. So if you want some like interesting like mindset and principles about DevSecOps, I would encourage Zane's talk. If you want sort of a collection of like practical tips and tricks from a bunch of companies, my AppSec EU talk was just like a condensed many of those. So if you are curious about the pros and cons, like a nice overview of SAST and DAST, Ofer's talk is quite nice. Justin, the author of Brakeman, wrote this talk on like building custom AST matchers in a couple different languages, which I thought was quite nice. If you're curious about what cases give DAST tools trouble, Robert's talk is quite good. There's a number of talks about starting AppSec programs. One I want to call out in particular is Leafs, because he also referenced a lot of research that he found useful. So when I saw him referencing all those other things, I was super excited because then you can follow up with those as well. So I've been moderating a couple of security automation panels. So this one from AppSec Cali was recorded. Unfortunately, the other two were not. But I think this is a nice opportunity to hear what smart people at a bunch of places have done and how they think about things. A couple more talks. So a lot of people are thinking about scanning like code using static and dynamic analysis. But this first talk by Nick mentions like, hey, we have these config management tools. Can we just scan those for like potentially insecure configs? So I think that's pretty cool. Asta and Patrick's talk on how do we empower developers as well as invest in long-term wins, I think is great. And then finally, Arcades, data-driven bug bounty from BSides last year, basically using bug bounty data to inform where do you invest AppSec time? Like what types of issues do you have and where? We did it, everybody. Yeah, So thank you very much for your time. So I've taken notes on most of these talks, and I'm planning to write up some detailed summaries. I'm probably going to regret this, but I give you permission to flame me on the internets if I don't publish at least one in the next 2 weeks. I see a bunch of people taking pictures of this, so slightly scary. But yeah, so yeah, feel free to reach out to me on either of those. I'm happy to talk about this, and I think it's almost exactly 30 minutes. So I'm getting nods from the side. So thank you very much for your time. I'm going to hang out after this, and I would love to talk with you. But yeah, thanks, and have a great day.
Oh, on behalf of BSides San Francisco, I'd like to thank you for your presentation today.